Okay, for number 12 on the worksheet, it says to graph and find the intercepts. Since this is in slope-intercept form, I'm going to graph it using the strategy of slope and y-intercept. My y-intercept is -3, and so I plot that on the graph. -3 on the graph. When written in slope-intercept form, the number without the x has the -1/2. The number without the x is the y-intercept. To make sure we understand why that is the case, reminder that the y-intercept comes from letting x equal 0. That will give me the y-intercept. So if I take my equation, y equals -1/2, and I multiply that by 0 for x, -1/2 times 0 is 0. 0 minus 3 is -3. So my y-intercept is 0, -3. I can check that by doing that math. Put that there in case you want it. The rest of the way we graph is by using my slope. My slope is -1/2. So from the y-intercept, I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. I can continue that pattern the other direction too. Up 1, left 2, up 1, left 2, up 1, left 2. And that gives me the same line. From the graph, it looks like the x-intercept is -6. And so some students will put that down. I recommend that you try it algebraically as well, which means that you plug in 0 for y and solve your equation, because sometimes you can't see what the number is on the graph because it's a fraction or a decimal, and you can't see that on the graph. And sometimes you just make a mistake. You forget that there's a -1/2, and so you graph your line going up instead of down, and then you get it wrong on the test. But if you find the intercept this way, if you find the intercept that way, then you can double check that it's the -6. So I would add 3 to both sides and get 3 equals -1/2 x. Multiply both sides by -2. -6 is x. So that just double checks, and now I have my x-intercept.